Okay, today we're going to be going over 5-6, which is solving radical equations. But before we do that, we have a little bit of a quiz review. So if you wanted to pause the video for a second, have the students work through these questions. There's a fourth one down below, but we can pick that one up once the video starts back up. So for number one, find the inverse of the function. Okay, the first thing you want to do, inverses, you have to switch the x and the y. So normally f of x is a y. I'm going to write x equals, we'll have y plus 1 up there, and then a 3. So you have to think of the steps to get the y by itself. We're going to take both sides times 3 to get rid of that. Then we'll have 3x equals y plus 1. We'll subtract the 1 from both sides, and we get y equals 3x minus 1. So that is the inverse. Remember how to write that like this. That's the best way to write out your inverse. And then on the quiz, you're actually going to have to prove what you found is the correct inverse. So in order for me to do that, remember we need to do f of g of x, and we need to do g of f of x. We have to do function composition with both of those. This one, I'll just show you what this one looks like. So I'm plugging the inverse into my original function. So this is going to be what the inverse is, going into our original function. So that goes up top where the x is. We're going to put that in right there for the x. So it'll be 3x minus 1 plus 1 in the numerator over 3. So the simplification, we take care of that first. Then we have 3x over 3. Those 3's are going to cancel, and we just get an x. So we did find the correct inverse by looking at this one. Again, we still have to do this one to show 100% that it's completed. Okay? So next one is just addition and subtraction of functions. We have g of x is this and f of x is that. We're doing f plus g of x. So that means we're going to add those two together, and then f minus g of x, we're going to subtract those two. So the first one, f plus g of x, we're going to take those and add them together. All right, so it's going to be this one here plus this one here. Okay, so that'll look like this, 10x squared minus 3x plus 5. And we're going to add 13x plus 5. And then just combine like terms. So 10x squared plus 10x plus 10. And there's conveniently 3 10s in that question, but that's what we're going to get. Okay, so for f minus g of x, we have to subtract them. And remember, this right here means we're going to have to distribute the negative through the g function or change all the numbers, the signs, okay? That's the way that works out. So we will have 10x squared minus 3x plus 5, and we're going to subtract this whole thing. So I'm just going to write it where the signs are switched. Okay, and then we just combine like terms again. So this would get me to a 10x squared, and we have a minus 3x and a minus 13x, so that's minus 16x. And then a 5, a positive 5, negative 5, those will cancel. So this is all we get for f minus g of x. Okay, and you need to label those like so. For the last one that you can see on the screen, okay, we're doing multiplication and division. And if you got those down, you feel pretty confident about those, you can go ahead and start the graphing question. Okay, but for multiplication, we're going to take our f times g of x. So that's going to be, usually we want to write the little one first. So that's our 13x minus 5. Taking that times 10x squared minus 3x plus 5. We're just going to kind of FOIL this out, okay? So we just take the 13x through. That gets me to 130x cubed minus 39x squared plus 5 times 13 is 65x. And then we'll do our next row. So that's the 13x through. Now we're taking the negative 5 through. So take that through there. So negative 5 times 10x squared is negative 50x squared. Remember to line it up with the other x squared. And then we have a plus 15x and then a minus 25. combine like terms here, we will get 130x to the third minus, that gets me an 89x squared plus 7080x minus 25. So that's what we get when we do the multiplication. Now the division, this one is pretty easy. You just have to remember your domain restriction piece. So it's going to be f over g. So f is the 10x squared. So 10x squared minus 3x plus 5. That's my f function. My g function is the 13x minus 5. So that's what we get for the division question. But we got to remember what our domain restrictions are. So you look at the bottom, set it equal to 0, and figure out what you cannot plug in. So 13x minus 5 equals 0. We're going to add 5. You get 13x equals 5. Divide by 13. So then that tells me x, if I wanted to get a 0 down there, x would be 5/13. But we cannot have that because we cannot have a 0 in the bottom. So this is the domain restriction that goes along with that question. Okay, so you got to have the division piece as your answer along with the domain restriction. Finishing out the quiz review, graph this function and give us domain and range. So if you remember what we did yesterday, every time we did these, whether it be square root or cube root, you're just starting with a basic XY chart. But then you need to remember, we need to find these perfect squares. All right, we looked for square root of 0, square root of 1, square root of 4, and square root of 9. We figured out what we could plug into here to get us those square roots, those radicals. So that's what we started with. So what plus 3 gets me a 0? Well, that would be a -3. What plus 3 gets me a 1? That's a -2. What plus 3 gets me a 4? That one should be pretty easy. A 1. What plus 3 gets me a 9? That's a 6. And then after we figured those numbers out, we actually put them in to evaluate. So -3 plus 3 minus 4. So we saw that that gets us a 0. So 2 times 0 is again a 0. So 0 minus 4 is -4. Going again with the square root of 1, or with our -2, excuse me. So we have square root of 2, and we got -2 plus 3 underneath there, minus 4 on the back end. So in here, that gets me to the 1, like we saw here. So square root of 1 is just a 1 times a 2, so this is a 2. Minus 4 is -2. All right, and then you can kind of continue the pattern. You'll see that you're going to get a 0 and then a 2. All right, then you go ahead and graph those. So we have -3, -4. That's that coordinate, -2, -2, right there. 1, 0, right there. 6, 2, right there. And then we just connect the dots. Remember, there's not going to be anything down here, because if I had numbers from this area, then I would have a negative underneath my radical, which is undefined. Okay? Domain and range, we got to finish with that. So whatever your first coordinate is, that generally tells you your domain and range. So x is going to be greater than or equal to whatever the x value is, which is -3. And we can look here too. That lines up with -3. And then my range, y is going to be greater than or equal to -4. Okay, and we can see that that lines up with that y value right there. So that would be the domain and range. Okay, hopefully this helped you get ready for the quiz. So pause the video, have the students take the quiz, and then we'll get rolling with the lesson for the day. All right, so we're going to work through solving radical equations. You have a note sheet available for you. It's in the description below if you need a copy of it, okay? So we're going to be working with these, and it should seem familiar because we've actually solved radical equations before. There's a couple things that should seem familiar and a few that might be a little more difficult, okay? Starting out with some simple review here. So when I multiply the square root of x times the square root of x, what does that give me? Well, I can follow the rules. We've done the radical rules before, where if you're multiplying the same square root, so this would be a square root, if I'm multiplying the same thing, then I multiply the stuff underneath. So this would turn into the square root of x squared. And now, evaluating square roots, you guys know that if I have something that's squared underneath there and I'm taking the square root of it, it just undoes the square root. So that gets me to just an x, all right? So this is a property here Or if I take the square root of exactly the same thing, I just get whatever is underneath the square root, and those radicals cancel out, okay? That's how that one works. So, looking at the next one here, I have the square root of x plus 1 times the square root of x plus 1. If you're following the original process here, you were thinking, well, I had to FOIL this out. I have to multiply this whole thing out, take this one times this one, and FOIL it out. Well, that's not the case. It's easier than that. I have the same thing here as I do here, both perfect, or both squares. I have the same thing here as I do here. Those are both the square root of x plus 1. So following the rules, I just would get an x plus 1 here, okay? So that's what I would get out after I multiply those. For addition and subtraction, you have to remember how you can add and subtract radicals, okay? In order for you to do that, you have to have exactly the same thing in the radical here. So this square root 2x matches with this square root 2x, so then I can add the numbers in front, okay? So what's in front here is an implied 1. So I can add that 1 with the 3, okay? But the square roots always come last when I write out the answer, so really I only have the 4 there. I can't do anything with it. So I have 4 plus, I put this 1 with this 3, so plus 4 square root of 2x, and that is your answer for that one. I can't do anything with the 2x inside there because I'm adding and subtracting, so that tells me that I have those like terms. Okay, so this one here is going to kind of have a combination of things, combination of rules. So we have multiplication and we have some addition, subtraction going on, all right? So right here is where I'm talking about the multiplication. That negative in front of the parentheses means it has to go through it. It has to distribute to those, all right? So that's your first step. Order of operations tell me to multiply that through first. So 4 minus 2 minus 3 square root of x. Now that negative does not multiply into this, okay? It would just turn whatever is on the outside negative, or it would multiply whatever is on the outside, okay? Plus square root of xy. Now combine like terms. The only thing we can do here is these right there. We can only combine those. So 4 minus 2 is a 2. And then we have these radicals just kind of trailing behind here. And that's it, okay? Now, you might be thinking, well, why can't I put this one with this one? Because there's an x in both of them. Well, it has to be exactly the same thing underneath the radicals in order to add or subtract them. When it comes to multiplication and division, you can multiply and divide whatever you want, but when it's addition, they have to be the same, okay? So we're looking at equations here, and I gave you these steps down on your sheet, okay? So the first thing to do, always isolate the radical to one side of the equation. Get that square root by itself. We always work to get the variable by itself. Here the variable will be underneath the square root, so you're going to have to work to get that by itself. Then, raise each side of the equation to a power equal to the index of the radical, and I'll show you what the index of the radical is. If I have a square root or a cube root, okay, that little number right there is the index. Okay, so if I have a cube root, I'm taking both sides to the third power. If I have a fourth root, I'm taking both sides to the fourth power. Okay, this is a square root, so really this is just an implied 2 that's inside that little index there. That's the radical, okay? So a square root has a 2 inside there, but you don't write it just because it's kind of implied. So step 3, solve the resulting polynomial equation. Check your results, okay? The check your results part is kind of important on these because sometimes when you're doing square root equations, you can end up with negatives as answers, but then when you plug them back in, they won't work, okay? So let's try one starting out here. So solve for square root y minus 2 minus 1 equals 5. Well, first step, get the radical by itself. That is this stuff right here. So I'm going to get that by itself. So you should be able to see that the 1's got to go. So add 1 to both sides. So square root of y minus 2 equals 6. Once we have that square root by itself, that radical by itself, take both sides. That's a square root, which is like an implied 2. Take that to the second power. And I have to do that to both sides. Whatever I do to one side, I have to do to the other side. Okay? So that square root's going to cancel with that exponent. So we have y minus 2 equals 36, because that's 6 squared. And then we can add 2 to both sides to finish out. You get y equals 38, okay? And then if we plug that back in, double check it quick. So square root 38 minus 2 minus 1 equals 5. So this is square root of 36 minus 1 equals 5. Square root of 36 is 6. So 6 minus 1 equals 5. Yeah, that checks out. Okay, 6 minus 1 is 5, so you get 5 equals 5. So what happens if we have one like this, where there are two radicals in the question? Okay, this is the newer questions where you haven't seen them in Algebra 2 yet. You may have seen them in Algebra 1, but that was a while ago. Okay, so the first step still applies. Isolate the radical on one side, but again, there's two radicals here. We have this one and we have this one, okay? So you want to isolate the bigger one, which it's already done, okay? So isolate the larger of the two radicals. That's your first step, all right? Since that's done, I can jump into right away squaring both sides, okay? So right away, square both sides. All right, so on the left, you have a single square root, so that index or that radical will cancel with that square. We got x minus 12. Now on the right, what your brain might want to do is you're like, well, distribute that. Well, we've talked about this a ton. You can't distribute because there's a subtraction there. So undo that. We cannot distribute there. So what you're going to have to do is FOIL this out, all right? Like so, 2 minus square root x, 2 minus square root x. You're going to have to FOIL it like that, okay? So we've done one of these a while ago, but it might not be fresh in your mind, so let's review how to FOIL one of these, okay? So FOIL is the same for most processes. You're taking the first, outer, inner, last. So 2 times 2 is 4. And then you have to remember, how do I take 2 times the square root of x? Well, since it's a whole number times the radical, you just put it on the outside. So minus 2 square root x. We're doing the same thing here. So minus 2 square root x. And then we have square root x times square root x, but there's a negative in front of both of those, so that would be plus x. And that's what it looks like after you FOIL it. Then you're going to have to combine like terms here, which I'm going to write that back in our problem over here after I do that. So it's minus 4 square root x plus x, okay? That's what we get after we FOIL that out. So now you're like, well, we didn't really fix much because there's a square root in there again. True, there is a square root in there again, so now you have to go through the process again. So isolate the square root here and then square both sides, all right? So let's move everything away from this. Okay, so that's right here is the thing we're looking to get by itself. So let's go and do kind of 2 steps at once. Move the 4 to the other side, and we're moving the x to the other side. And you should see conveniently that the x's are going to cancel out. All right, so we have negative 12 minus 4 is negative 16 equals negative 4 square root x. And now I need to divide both sides by negative 4. It looks pretty easy from here. So negative 16 divided by negative 4, that's a 4. All right, so we have 4 on the left and square root x on the right. And you could flip-flop that around if you wanted to, that's okay. But then you should see your last step, just square both sides, and you get x equals 16. Okay? Those are about as involved as they're going to get. Sometimes the x's will cancel out, sometimes not. And we'll go through one of the examples later on where the x's don't cancel out and you actually have to square or FOIL again. Okay? So if I look at this one where I got that 16, so this would be 16 minus 12, so that would get me a square root of 4, okay, equals 2 minus square root of 16. So square root of 16 is 4, so over here I'll have 2 minus, I'll write the square root of 16 there. All right, so move this stuff out of the way so I can show you what happens when we check it. So I put my square root of 16 in there, simplified down a little bit. So here I get a 2. Okay, here I get a 4, so I'll get 2 minus 4. And then we have 2 on the left still. 2 minus 4 is negative 2. And now we're like, well, That doesn't work. 2 cannot equal negative 2. You're right. So this does not work. This question has no solution. Okay? So that's why you got to check your answers in the end, because occasionally you'll do all the work and it looks like you get an answer when in reality there is no solution to the problem. So double check your work in the end. Okay? So looking at another example. Let's look at one of the harder ones. I'll come back to some of these later in the video, and we can try these again if you would like to. Okay, so let's skip down to a harder one. All right, so let's look at this one here. Step 1 says isolate the radical. Okay, so get the radical on one side. Well, again, you got 2 radicals here, so isolate the bigger one. Well, both of them have 2 things underneath there, so really it's not going to get us very much or get us a different answer besides. So really it's not going to make a difference if I switch from one to the other. So let's go ahead right away, square both sides. Now this one has kind of an uglier situation because you're foiling with this. All right, on the left we got x plus 6, on the right you got a foil. So let me get rid of this, write it out again so we can foil. The process is the same exact thing that we did with the little one. Okay, you do first outer, inner, last. So that gets me 25. All right, so I'm taking 5 times that. So I can't put it inside there, so I have to put the 5 out front. 5 square root x plus 1. Now we're taking this one, so that's the inner. Okay, so again, it's going to be the same as this. So minus 5 square root x plus 1. And then we take the last 2. Oops, I cut it off. So we have square root of x plus 1 times square root of x plus 1. Negatives in front of both of those. So that negative turns to a positive, and that square root of x plus 1 turns into just x plus 1. Okay? Now again, the process is exactly the same as the last one. Combine like terms, isolate the radical, square both sides, go from there. Okay? So you should be able to finish this one out. So try to jump ahead of me if you can. So on the left, we have x plus 6 again. On the right, that 25, let's look for another like term. We got a 1 down here, so that turns into a 26. Okay, we have the 2 terms with the radicals. Excuse me, that should be a negative 10. Square root x plus 1, we're just adding those numbers in front because the radicals match. And then we have the plus x. So just like in the last one. We're going to move the 26 over and move the x over. That goes away, move the x over, and again, conveniently, the x cancels out. Okay, so we have negative 20 equals negative 10 square root x plus 1. And you have to divide both sides by negative 10 to get rid of that. All right, and then that gets us to a 2 over there on the left. So let's continue our work over here. So we have a 2 equals square root x plus 1. And again, we got that isolated radical, square both sides, and it's not too bad from here. Okay, square root 2 squared is 4. And then when I square this one, I don't need to FOIL it because it's just a single radical by itself. I had to FOIL this because it was a number and a radical. Okay, so here, that square root's going to cancel out. We get x plus 1. Subtract the 1 from both sides, and after all that work, we get x equals 3. Okay, let's double check it here quick. So plugging in a 3 here. So 3 plus 6, we get square root of 9 on the left. And then over here, we're going to have 5 minus 3 plus 1, square root of 4. All right, so square root of 9 turns into a 3. I'll write it down here to kind of continue my check. So 3 equals 5 minus 2. Square root of 4 is 2. So you get 3 equals 3. And yeah, this one works. Okay, so this one's good to go. All right. So let's look at something like this. And again, I'll come back to the other ones. I would recommend going back through these on your own individually. All right. So looking at something like this, we talked about this in one of our classes before, where you have a 1/3 exponent up there. All right, most of you should have done this in Algebra 1, so you kind of have an idea what the 1/3 exponent means, but a fractional exponent is the same thing as a square root or a cube root or a fourth root, something like that, okay? So in order to get rid of that 1/3 power, you're going to isolate that term with the 1/3 power, which is this, and you're going to take both sides, raise it to the third power, okay? So really, if I rewrite this over here, just so you can see it, I'm going to keep it as that fractional exponent. If I have, so 1/3 is a cube root, and that's what this is going to look like, okay? So again, you would isolate the radical here by moving the 5 over and take both sides to the third power. So I'm going to show you how to do it with this one, okay? So 3y plus 1 raised to the 1/3 power. We're moving that 5 over, okay? So that equals a -5. Then you're going to raise both sides of this thing to the third power, okay? Because these are going to cancel out. If you remember your power rule, when I take a power to a power, they multiply. So 1/3 times 3 turns into just a 1. Okay, so this effectively is turned into just 3y plus 1. And on the right side, we have a -125. From there, should be pretty straightforward. Move the 1, divide the 3. Okay, -1, -1, we get 3y equals -126. And then divide both sides by 3. And we get y equals -42, which you could plug that in and check as well, okay? So that's how you do it with a fractional exponent. So looking at this one, it's kind of like the last one where it's a radical or a power or a root that's greater than a 3 or greater than a 2. You're used to square roots, okay? This is a 6th root. So what you're going to have to do is get this by itself and then take both sides to the 6th power, okay? So you'd move the 4, move the 7, take both sides to the 6th power, okay? I'll come back to that one and I'll work through it in a little bit. This one as well, okay? But I want to finish out with the general notes on solving radical inequalities, okay? So you have a few steps written down for you on these again. So step 1, if the index of the root is even, identify the values of the variable for which it is non-negative, okay? Because remember, we can't have negatives in here. We can't have negatives in an even root, okay? So if it's even, it's got to be 2, 4, 6, 8, 10, something like that. Then you're going to have to find the values which h cannot be, okay? Step 2, solve the inequality like normal, okay? Remember, when I'm working with inequalities, if I divide both sides by negative, that's got to flip, okay? And then you test values to check your solution. So you plug them in to see if they work, all right? So let's check this example out. We got a little bit of information with this one, okay? So starting out, I said it was an even root, so we have to look at this stuff first. All right, so it says, since the radicand of a square root must be greater than or equal to 0, first solve 3x minus 6 is greater than or equal to 0 to identify the values of x for which the left side of the inequality is defined, okay? I need to first set this stuff greater than or equal to 0 because it can never be a negative number, all right? So using this right here, 3x minus 6 is greater than or equal to 0. Solve that. Go ahead and solve that. Okay, I'll add 6 to both sides. I have 3x is greater than or equal to 6. Divide both sides by 3. X must be greater than or equal to 2. That's part of the solution. Okay, now, second part of it. I take this like normal, like it started out as, and I just solve it. So I have square root 3x minus 6 plus 4 is less than or equal to 7. So solve this like you would normally solve a square root equation. Okay, move the 4 over. I got square root 3x minus 6 is less than or equal to a 3. All right, so that square root is by itself. Now think about what you're going to do on your next step. We want to get rid of the radical, so square both sides. Okay, so then that goes away with that. We have 3x minus 6 is less than or equal to 9. Keep going here. add 6. All right, we get 3x is less than or equal to 15. Divide both sides by 3, and we get x is less than or equal to 5. Okay, so we look at this now. So we have to consider both of those inequalities that are underlined. This one and this one. So this part tells me I got to have everything bigger than or equal to 2. This one tells me I got to have everything less than or equal to 5. Okay, so your answer has to be in between 2 and 5. So if we write that out, we got to be bigger than or equal to 2 and less than or equal to 5. That's what our answer should be according to this inequality and this inequality. All right, it's between 2 and 5. So to check one of those, let's check something in between 2 and 5. So let's say we want to plug in 3. It's right in the middle. Okay, let's take that just as a final check. We're plugging in a 3. Okay, so we have square root of 3 times 3 minus 6 plus 4 less than or equal to 7. So you might need to use a calculator on some of this stuff, okay? Just because of the number that I picked, it might not be the best number. We're just going to go with it. So this would be square root of 9 minus 6 plus 4 less than or equal to 7. So we got square root of 9 minus 6 is going to be a 3 plus 4 less than or equal to 7. So you should be able to kind of rationalize through this. The square root of 3 is definitely not going to add to 4 and get me above 7. So yeah, this one checks out. Square root of 3 is like 1.8, I think. So 1.8 plus 4 is going to be about 5.8. So yeah, that checks out. Everything's less than 7. So this is going to be our answer right there. Okay? That's how you do square root inequalities. Here is your assignment for the lesson today. Okay? A lot of us pretty much just number crunching through those equations. So go ahead and give it a shot. And if you wanted to have a little bit more practice, I'm going to go back and work through the example that I did not finish. All right, so this one's a little bit more difficult. Okay? So we want to try to work through that one. So follow your steps that we listed before. You isolate the radical. Okay? So that means this has got to go over, and I got to get rid of that negative there. Okay? So I'm going to subtract 2x from both sides. And then I have, so that gets me a negative square root of 6x plus 4 equals negative 2x. Multiply both sides by a negative 1 to get rid of that. Okay, we're just trying to isolate that radical. So then we have square root of 6x plus 4 equals 2x. All right, then you square both sides because we have the square root isolated by itself. Okay, square root or square both sides. That takes care of that. And then on the right-hand side, so this is where it's a little bit different. Okay, 6x plus 4 on the right-hand side, we're going to have 4x squared. So you have an x over here and an x squared over here. So whenever you have an x squared and an x in a problem, you're going to have to do some factoring. In order to factor, you have to have it set equal to 0. So we're going to move the 6x and the 4 over. Okay, so minus 6x minus 4. That's going to get rid of it over here. We'll have a 0 on the left, and then we have 4x squared minus 6x minus 4. Okay? So factoring something like this. Well, everything is even, so that means I can take out a 2. So let's cut out the 2. All right, so let's rewrite it with the 2 is out. All right, normally if it was just factoring, you would write it as 2 times something. But since it's a solving equation, you don't need to do that. So we'll just take out the 2. So I have 2x squared minus 3x minus 2. That's going to make it a little bit easier for factoring. Okay, so let's move this up. And we're doing SMILE method. So 2 sets of parentheses. You got a 2x there, an x there, and now we're kind of guessing and checking where the other numbers are going to be. So your only options for this are a 2 and 1, just like the front options were just a 2 and a 1. How can we put the 2 and the 1 in there to get us a 3? Okay, well my suggestion is to try to get a 2 there, which would get me to 4x, and then we'd be left with the 1 there, which would give me a 1x. How can I use a 4x and a 1x to get negative 3? Well, this one's got to be a negative, and this one's got to be a positive, okay? That's the correct factorization. Now we got to get our zeros, okay? Because it's set equal to 0, we're solving. So this one, pretty straightforward. If I set that equal to 0, you're going to get x equals -1/2, okay? Similar process with this one. You should be able to kind of visualize that. If I set that equal to 0, I get x equals 2. Now, you definitely got to check these if you get two solutions, okay? Because we're thinking that those two might be our solutions. We have a -1/2 and a 2, okay? So putting that in there, let's do the -1/2 first. All right, so I'll use my red ink to check that out. So 2 times -1/2 minus square root of 6 times -1/2 plus 4 plus 4 equals 0. So 2 times -1/2, that's a -1 right there. And then inside my radical, so 6 times the -1/2, that's a -3. So inside here, we're going to have a 1. So square root of 1 equals 0. So -1 minus 1. Okay, so looking at that, that's -1 minus 1. That definitely does not equal 0. So this one does not work. Okay, I'm going to move some of this stuff out of the way and we'll try the 2. So 2 times 2 minus square root of 6 times 2 plus 4 equals 0. 2 times 2 is 4. Minus, underneath the radical, we're going to have 6 times 2 is 12 plus 4. Okay, 4 minus, that's going to give me a square root of 16 equals 0, which, yeah, that one's going to work out. 4 minus 4 does equal 0. So the x equals 2 is our only answer. Even though we got two answers in the end, the x equals 2 is our only answer. Okay? These ones are kind of the harder ones. All right? Where you end up factoring in the end. So you're going to have some where you end up factoring in the end like that. Okay? Let's jump ahead to this one. Okay, let's take care of these two. So I'll go ahead and work through these two fairly quick, and I'll jump to that last inequality question. Okay, so isolate this, add the 4. So I have 7, 6 root of 5m plus 4 equals 14. Divide both sides by 7. Hey, that works out kind of nice. We get a 2 over there. So we have 6 root 5m plus 4 equals 2. And then here, since we got that 6th power, or 6th index there, take both sides to the 6th power. All right, that takes care of that. We got 5m plus 4, and then you're like, well, 2 to the 6th, I don't know what that is. We'll start multiplying by 2. So you got 2, 4, 8, 16, 32, 64 is 2 to the 6th. All right, subtract 4 from both sides. That goes away. We get 5m equals 60, and it's going to be a fairly decent answer. So 60 divided by 5, that gets us to a 12. So m equals 12. Okay? You can check that one if you want. I'm going to tell you that it's going to work. All right, let's finish out this last one, and then we'll finish out with that inequality question. So same thing. Add 4. Both sides, we get 9. Cube root now. 3h plus 3 equals 81. And again, works out kind of nice. 9s go away. 81 divided by 9 is 9, so we'll have cube root of 3h plus 3 equals 9. And then we cube both sides, okay? So then we have 9 to the 3rd power, which you might need your calculator for that one. So that takes care of that. We got 3h plus 3. 9 to the 3rd power is 729. All right, keep going. Minus the 3. So we have 3h equals 729 minus 3 is 726. Divide both sides by 3. And that should get us down to something that's fairly nice. So 726 divided by 3 is 242. So that's your answer for that one. All right, last question. We'll make sure we know how to do these by the time we're done. We're looking at this last inequality. So first thing you want to do, take that stuff underneath there, set it greater than or equal to 0. Okay, because we have to be bigger than 0 when we plug those values into there. So from there, just go ahead and solve it like normal. Minus 5, you get 2x is greater than or equal to -5. Divide both sides by 2. Okay, you get x is greater than or equal to -5/2. That's part of our solution. Okay, keep that off to the side. Now we're going to work with this one like normal now. So add 2, we get square root of 2x plus 5 less than or equal to 11. Now we can square both sides. That radical is by itself. That takes care of that. 2x plus 5 less than or equal to 121. Okay, let's keep going. Minus 5, minus 5. So 2x is less than or equal to 116. Divide both sides by 2. And you get x is less than or equal to 58. Okay, so we have kind of some bigger numbers going on here. We got less than or equal to 58 and greater than or equal to -5/2. So we're between -5/2 and 58. So again, just like the last one, when you say between two numbers, you write it like this. Okay, and I'm not going to check a ton of numbers, but just take my word for it that that is the correct answer. Okay, so hopefully you know how to do this better now. And again, if you need some more review, I would go back and watch the video, or you could send me an email with some questions. Thank you for watching.